Okay, I'm going to go ahead and read this article out loud. I want you following along with the text as I read it. I don't want you to just sit and listen or zone out. I want you to be an active participant in this read aloud, meaning your eyes are going through each word as I say each word. So, liquid oxygen. The caption of this picture says oxygen is most commonly found in the gas phase, but scientists can make it change phase into a liquid. In your daily life, oxygen is everywhere. It's in the air all around you and even inside you, traveling from your lungs to every cell in your body. You probably think of oxygen as a gas because that's how you encounter it, but it isn't always a gas. Oxygen can also exist as a liquid with a beautiful blue color. However, you'll never see puddles of liquid oxygen on the ground, and you can't buy a bottle of liquid oxygen at the store. Oxygen is very different from water, the most common liquid found on Earth. Scientists can produce liquid oxygen, but it's not easy. Why is oxygen gas all around us while liquid oxygen is so rare? The role of attraction. Liquid oxygen is much harder to find than liquid water because oxygen molecules aren't strongly attracted to other oxygen molecules. Every substance has a certain level of attraction between its molecules that pulls the molecules towards each other. This molecular attraction is stronger in some substances, like water, than it is in other substances, like oxygen. Molecules in liquids and solids stay close together because of the attraction between the molecules. In the gas phase, molecules are able to move away from each other because they have a lot of kinetic energy. But attraction between the molecules still keeps them in the same general area. Different substances have different levels of attraction, but the level of molecular attraction for any one substance is always the same. Since attraction never changes for a substance, something else has to change before the substance can change phase. You can think of each substance as always being in a game of tug of war at the molecular level. Attraction is always pulling the molecules together, while kinetic energy allows the molecules to move around. Substances change phase when either molecular attraction or kinetic energy wins the tug of war. And since each substance's molecular attraction is always the same, the change must be in the amount of kinetic energy the molecules have. A large increase in kinetic energy can move the molecules so fast that they overcome the pull of attraction and move away from each other. The opposite is also true. A large decrease in kinetic energy allows attraction to overcome kinetic energy and pull the molecules toward each other. Here we have an image showing substance A and substance B. Let's read the captions here. It says substance A is a gas and substance B is a liquid. They are at the same temperature. Why is one a gas and one a liquid? Substance A has weaker attraction, and its molecules have enough energy to overcome the attraction between the molecules and fly apart. Substance B has a stronger attraction, and its molecules don't have enough energy to overcome the attraction between the molecules. Therefore, its molecules stay together. For oxygen gas to change to a liquid, the attraction that pulls the oxygen molecules towards each other must overcome the kinetic energy that pulls them away from each other. Because the attraction between oxygen molecules is weak, a great deal of kinetic energy needs to be removed from the molecules by making the oxygen very cold before their attraction can pull the molecules towards each other. Using attraction to make liquid oxygen. Scientists use their knowledge of attraction to produce liquid oxygen. They know they need to allow the weak interaction between oxygen molecules to pull them together. They do this by transferring energy out of the oxygen, lowering the temperature of the oxygen molecules until their kinetic energy is so low that it can't overcome the attraction between molecules. The temperature required to turn oxygen gas to liquid is far colder than what's required to turn water vapor to liquid. That's why oxygen needs to be extremely cold to change phase into a liquid, while water doesn't need to be very cold at all. When scientists need liquid oxygen, they can get it by separating oxygen molecules right out of the air. Air is a mixture of nitrogen and oxygen combined with small amounts of other gases, like water vapor and carbon dioxide. Since the gases in the air have different levels of molecular attraction, scientists can separate them by sending the air through a machine with different tanks that are at different temperatures. In the first tank, scientists decreased the temperature enough to condense the water into a liquid. That is, they decreased the kinetic energy of the molecules so the attraction between them can pull the molecules together. The liquid water that forms in the first tank is drained away. Then, the remaining gases are put into a second tank and cooled below negative 183 degrees Celsius, which is negative 297.4 degrees Fahrenheit. That's cold enough that the molecules in those gases have very little kinetic energy to push molecules apart. Because of this, the attraction between the molecules pulls them together and condenses the gases into a liquid, just like the water in the first tank. This liquid contains the molecules from the remaining gases in the air, including oxygen. The liquid mixture is then moved into a third tank that is heated up just a little so that the nitrogen evaporates. The kinetic energy of the nitrogen becomes too strong for the attraction between the molecules, and they escape into a gas. When the nitrogen evaporates, the liquid left behind is mostly oxygen. Oxygen isn't the only substance that's hard to condense because of weak attraction. Hydrogen and methane also have very weak attraction, and so are difficult to condense. Like oxygen, these are substances we tend to think of as only being gases on Earth. However, also like oxygen, they can become liquid if they are cooled enough. Cooling these substances just a little won't cause them to condense. These gases reach extremely cold temperatures before condensing into liquids. It's all about the attraction.